Hi everyone, and welcome back to another tips and tricks clip. In this video I want to show you how we can set a surface eccentricity and how it affects the deformation and internal forces of a surface. So with a surface eccentricity we can set an offset for a surface, and we can see here our first example for that with different perspectives. We have two surfaces next to each other with different thicknesses. The first one has a thickness of 180 millimeters and the second one 300 millimeters. Before we begin with entering an eccentricity, you might notice that right now there is no thickness displayed on these surfaces. So for a better view, we can change that under the display menu. Here, if we expand rendering, we can find solid model and surfaces. Then there's the option field inclusive thickness. And now we can also see the different thicknesses of these surfaces. Alright, now if we want that these two surfaces are even on their top edges, we can set an eccentricity. For that, we can open the edit surface dialog with double clicking on the surface. Then on the support and eccentricity, we can find down here eccentricity, and we can enter a value for that, like 60 millimeters. And because my global z-axis is oriented downwards, I will enter -60, and after that we can click OK. Now we can see the adjacent surfaces with equal top edges. So next, our second example is a typical one where we do need a surface eccentricity. If we have, for example, a thickness jump within a plate, but both surfaces should be again planar to each other. The first plate has a thickness of 200 millimeters and the second one 500 millimeters, and again we can double click on this and type in as an eccentricity 150 millimeters. After clicking OK, we can see both edges are now even with each other. Now let's take a look at the calculation and then on the results. We can see here a very simple example. We have two identical surfaces with hinge supports, and in order to compare the results, we will move one along the z direction, let's say 300 millimeters. Then we will apply a surface load on each of these surfaces of 2.5 kilonewtons per square meter. And next we can click up here on the symbol called calculate all. Now for a better view, we can turn on the wireframe model and have a look at the results. The moment distribution mx or my for this surface is like it should be, or like we would expect it. At the second surface with an eccentricity, we can see that on the free edges, restraining moments occur. And this is because if we define an eccentricity, we can say that virtually invisible rigid surfaces are formed along all boundary lines, which are rigidly connected to the original surface, and this causes the restraining moments. And therefore, as a tip, only apply surface eccentricities on inner surfaces and not on the surfaces with free edges. So thank you for watching. If you like this video, don't forget to like and subscribe, and until next time.